Hello everyone. Today we are going to start new topic simple pendulum. We take this topic from chapter oscillation in physics. So we do the expression of simple pendulum in terms of tension, length and gravity. So what is simple pendulum? A simple pendulum consists of a mass metallic bob and a weightless and flexible string and inelastic. So a bob is suspended through a rigid support and the mass of this bob is m. When this bob, if we take at point A and release it, it moves in to and fro like a simple pendulum which is moved. The from point O to A, it covers displacement x. X displacement. The length of metallic bob thread is L and the tension in the string is T. Now the this is a metallic bob, so it has mass or weight. So its rate is vertically downward. Alright, and we take if this bob at point A, its mass can be changed from this to like as this. At point A, this is point A. This is a bob. Its mass can be like that, which is mg. Now consider a metallic bob of mass m. Alright, the length of string BL and tension or force in string is T. Now at point A, the simple pendulum weight is dissolved into two rectangular components, which is mg cos theta and mg sin theta. You see that the pendulum has always acute angle theta. So this is angle theta. So this is also angle theta. This is alright. So we resolve it into two rectangular components. First is mg cos theta, because theta is with horizontal line, and second is mg cosine theta. Here minus sign will become, because if we raise from this point bow, it exert a force against displacement. Alright, so at point A, it resolved in two rectangular components. First is tension or force, T is equals to mg cos theta. Alright. Second is force against displacement, F is equals to minus mg sin theta. Minus sign indicates the force exerted against displacement, x. Now in triangle, it is equation number 1. In triangle O, this is point O, initial point O. In triangle OAS, we apply sin theta identity. in triangle OAS. Sine theta. What is sine theta? Perpendicular upon hypotenuse. Here this is 90-degree angle and this is perpendicular. X is perpendicular and AS is hypotenuse. So we can write OA upon AS, which is perpendicular upon hypotenuse, or it is equal to X by L. Alright, now put X upon L. Now by Newton's second law, F is equals to ma. Now here the acceleration is alpha in this simple pendulum case, so m alpha. Now put equation 2 and 3 in equation number 1. Put equation 2 and 3 in first. So this is equation first become F is equals to minus m alpha into X by L. Alright. Now from let it is equation number 4. From equation first and 4, its left hand sides are equal, so right hand side also equal. So this is minus mg x by L. Here sin theta is x by L. From this is equals to m alpha. Alright, so m cancel. Here alpha value is minus g x by L, and this is displacement, x by L displacement. So we say that x alpha is directly proportional to minus x, which is displacement, and this is alpha is force against displacement, so it is directly proportional to displacement. This is equation number 5. Hence we say that the force is executing SHM. SHM is simple harmonic motion. Now at last, from equation 5th, x upon alpha is equals to m upon g. So if we take the square root of T tension, so this is under root L by, this is L is m, L by g. Here L is x, this is displacement, so this is displacement, this is gravity. So we prove that this expression by adding a constant T is equals to 2 pi root L by g. This. So this is the complete derivation of simple pendulum. Please note it down. So in next video we discuss about projectile motion of chapter 3, motion in a plane. So be ready for that video. Now thank you everyone.